Hello.
Hi.
Yeah, I think you can start.
Okay. Right. Everyone. So today we're gonna continue off of what Sean was teaching you guys yesterday, um, about the lemonade stand. So I'm gonna share my screen. Do you guys see my screen?
The screen.
Okay. Okay. Uh, so last time you guys learned about the lemonade stand, and basically it was a pretty simple type of machine learning where you guys used one variable, which was temperature, and then you guys used the temperature to sort of predict what the number of sales would be. And y equals 2x was sort of the equation that we were able to get. But now we're going to get into an example that's a little more complicated, but you don't really have to learn anything new. So this is the example that we're going to learn about today. It has a lot more variables than the first example, but it basically uses the same concepts as last time. It's just that it has more variables that we need to consider. Okay. So the example that we're going to be looking at. Oh. Okay. Anyways, the example that we're going to look at today is called Boston housing price, and basically, it has a lot more data than the lemonade stand one. Some examples include the rate of crime, and it's yeah. So we're looking at the rate of crime, and we're also looking at the number of rooms, for example, We're also looking at distance, whether it's close to a river. And finally, we're looking at column 14. And we're focusing on this column because this is where we're going to predict the price or the median price of a house in Boston. And the MEDV here in column 14 stands for the median value. So, and it's a little different from average because median is basically where we order the cost of housing in Boston in order from least to greatest, and then we take the middle value. And we use the median value instead of the average value because sometimes the average value can, with some outliers, such as housing that costs a lot, like 60,000, or housing that costs really little, for example, less than 10,000, can affect the average value. But when we take the median value, these outliers don't really matter that much. So that's why, in this case, we're using the median value instead of the average. Okay? And basically, we're taking all of these variables. So we're using all of these 13 variables, and we're trying to predict what the median value of housing would be in Boston. And this is similar to the last slide, except instead of these X and Y variables, we're now using the actual name of the data that we are taking into account. Okay. So, yeah, this is one example where we're taking the data from one row, and we can see that if we put in the value of these 13 columns of data, we get a value, a median value that's similar, somewhat similar to this 15.2 value. And that's how we're going to predict the median value in Boston housing. So, like before, we're going to go over the 4 steps that we have to use in order to do this. And first, we're going to prepare the data. And second, we're going to create a model. Third, we're going to train the model or fit. And fourth, we're going to use the model to predict. So, the data preparation, or basically all 4 steps are going to look pretty similar to the lemonade stand example. And I'm going to go over the code after I go over the slides. So here, we haven't gone over the code yet, but this 13 here, for the lemonade stand, you might remember that you put the number 1 instead of 13. And this is because in this example, we have 13 columns of data. So instead of just 1 column, which was used in the example here for the lemonade stand, we're now going to have 13. So that's why you're going to put the number 13 in here. And the number 1 here represents the fact that we have 1 column for the Y. Okay. And to explain some of the terminology that we use, so you might have noticed that the equation sort of follows a format of y equals w1x1 plus w2x2 plus ... w13x13 plus b. And so this model is basically called a perceptron. So all of these lines that you see that lead to this one y node is going to be called a perceptron. these W values that you see here, which basically represents the line connecting x1 to y, x2 to y, and so on, these are going to be called the weight. Okay? And the B value that you see at the very end, we're going to call this the bias. Okay? And this is sort of irrelevant, but sort of building off from the previous example, let's say we wanted to use 12 of these variables and sort of predict two values from those 12 variables. In that case, instead of doing 13 and 1, we're going to do 12 and 2, because now we have 12 different independent variables, and we're using those independent variables to find two dependent variables. And these two mathematical expressions are what we're going to get from that. But in this case, we're just going to do 13 and 1, since we're only interested in predicting the median value. Okay, so those are the slides for Boston housing price. So I want all of you guys to go to a new collab.research. I'm gonna send you guys a link. I think you guys should create a new one. I'm not sure if you guys have the link. Do you guys have the link to collab.research.com? Okay. Yeah, I'm just gonna put the link again, just in case. So here's the link. So I'm gonna wait like 30 seconds for all of you guys to get here. Okay, and I will get started. So, right, okay, so first, I'm gonna need to, so you may remember the first 4 steps. I'm just gonna write the first 4 steps down. First, we want to import some modules. So first, we're going to import the TensorFlow, and we're also going to import this as PD, and we're also going to import math. Okay, and these 3 you guys should have done in the previous class, I believe. So you import the modules, and step 1, we're going to prepare the data. At number 2, we're going to create a model. Step number 3, we are going to fit the model or train the model. And last, we're going to use the model to predict. Okay. So you don't need to write this down, but this is just for the sake of organization. Okay, so these are the 4 basic steps that we're gonna follow for today. Okay, and I need to send you guys the link to the data that we're using. So I'm gonna do that in the chat right now. So I'll post it here, and I'll post it in the live lecture notes. If you click that link, copy and paste it, we're going to use that link for our data. Okay? So first, just a moment. Hmm. Okay, there we go. So hopefully you guys can see a bit better now. Okay, so we imported the modules, and so now we're going to actually prepare the data. So we're going to do data path equals, and then single quotes, and then we're going to put in the link that I just sent you guys. So copy and paste this link, then you're going to go here and copy and paste it in between the single quotation marks. Okay? So this is our data path. And now we're going to do Boston equals PD, or we're going to use Canvas, and we're going to read CSV data path. Okay, and we're basically reading this raw data. And then we're going to do Boston.head. And what .head is going to do is it's going to get the top 5 rows of data. So if we, oh yeah, and don't forget to press the run button for each block. Okay, I'm going to run this. Oh, oops. There we go. So as you can see here, we have the first 5 rows of data, and we also have all 14. Is it 14? I'm pretty sure, yeah, 14 rows of data as well. Okay, so that's what .head is going to do. And sometimes we also like to get the names of the columns here. So you might also want to do print Boston.columns. Okay, and what this is going to do is it's going to print all the columns for us, just to make sure that we have them correct. Okay. So after we do that, we're now going to sort the independent and dependent data. So as I explained earlier, for the lemonade stand, we had one dependent and we had one independent variable. For this one, we have 13 independent. Let me look for the slide. Yeah, we have 13 independent variables, and now we have one dependent. So this means that independent, we're going to have all of these. So you can, using the columns that we printed, we can just copy and paste it into this. Okay. Does anyone have any questions? Or am I going too fast? Anyone? Is everything okay? Okay, I'm gonna assume that. Oh, okay, yeah, sure. I will pause here, and I'm gonna try to explain everything again. So we have like the lemonade example. We're gonna get our data from a file, a .csv file, and we're gonna read it into this here. Okay, and after that, we're going to do boston.head. And what that's going to do is it's going to get the top 5 rows of data. Okay, because for now we don't want like all the rows. We just want the first 5. And just to make sure, just to be safe, we're just going to print. You don't have to do this, but when you want to copy and paste it down here later, we want to print Boston.columns. And what that's going to do is it's going to print the names of the columns for us in an array. Well, not an array, yeah. So I will continue now. So since we sorted our the names of the independent variables, we're going to do the same for the dependent variables, or the dependent variable, since we only have one. And that's only going to be the median value. Okay? So all of these are independent, and only this is dependent. Okay? And this step is also optional, but we can again print them to make sure, print their shape, make sure that we're doing everything correctly so far. So we can do independent shape, and then dependent shape. So I'm going to run. And here we see that of the 506, we're getting the 13. So we have 506 rows, and we have 13 columns for the independent, right? Which is correct. And we also have 506 rows and 1 column for the dependent, which is also correct. Okay. And so if I were to explain that visually, we're basically getting all of this, but we're splitting it up so that we're getting the first 13 columns and all of the data for those 13 columns. And for dependent, we're getting the median value, the last column, and then we're getting all the values for that last column that correspond to that last column. Okay, so I'm going to wait for 30 seconds, or I'm going to wait for a minute at this step, so that if you have not caught up, you can do so right now. Okay, I'm going to move on now. So now we're done with step 1. So we have successfully prepared all of our data. So now it was kind of a long process for step 1. We're done with it, and now we're going to move on to step number 2. And that's to create a model now. And in order to create our model, we're going to do the same exact thing as the lemonade stand example, but except we're going to change just one number, I believe, to do that. Okay, so we're going to do the same exact thing. So we're going to do x is equal to TensorFlow and then layers.input, and for the shape, we're going to do equals 13 this time instead of 1. And the reason why is because this time we have 13 independent variables, otherwise known as x. Okay, so we have 13 of them, so that's why we're putting 13 here. For the y, we're going to do TensorFlow layers.dense. And for here, we're going to do 1. And the reason why is because we only have one dependent variable, otherwise known as y. Okay, and don't forget to put parentheses x, because we're doing this based off of x. And to simply explain it, we're going from x here to y. From x to y. So we have to base the y from what x is. So that's where we're going to do parentheses x. And then we're going to create our model. So we're going to have to do model is equal to TensorFlow models dot model x comma y, and what that's going to do is that's going to create our model, just like the lemonade stand. And then we're going to compile it. So to go over our steps again, step number 2, we're creating a model. And the way we're going to do that is we're going to do x is equal to this, and make sure to put 13 as the integer value, because we have 13 independent variables, otherwise known as x. And for y, we're going to do y equals, and then we're going to put number 1 here. And that's because we have one dependent variable, otherwise known as y. And we're all basing the y out of what the x values are. So we're going from x to y, or independent to dependent. So that's why we're going to have to include the x here. And next, we're going to actually do step number 2, which is create the model. So we're going to do model is equal to, and then we're going to do x comma y, because these x and y are our independent and dependent variables. And then we're going to compile our model. I'm going to wait around 30 seconds for everyone to catch up. And then we're going to move on to step number 3. And oh yeah, don't forget to run this one as well. Was a bit longer than 30 seconds. Okay, so step number 3. Now we're actually going to train our model. And this is the fit step. And okay, so I'm still sharing. Okay, so we want to train our model. So we want to do model.fit independent dependent. And for the first time, we can probably just do 10 times and see where this goes. So if we run, so as you can see here, we see the loss that, and the loss is around 33,000, and that's a really big number. And basically, our goal is to lower this number as much as possible. Okay, so as the machine or the model learns, as it's trained, this number is eventually going to go down, and it's going to decrease until probably around 20 something. But in order to do that, we're going to have to train it more. So maybe increase this number up to 100. And here, you see that the number drops considerably, right? So first it was like 33,000, right? But now it's like, let's see here, 56, right? But it can probably go more lower than that. So what we're gonna do is and what this is gonna do is it's gonna train it like over 1,000 times, but it's not gonna print all of the 1,000 all of the 1,000 times that it trains the model. So we're only going to see 10 of them. So let's do that. The number that we're getting is like 26, right? So this is a pretty low number, and as you can see, the number is going from like 26 to 27 to 26. So it's kind of like staying at this number. So we've brought it down from like 33,000 to 26. So that's a pretty good amount. So we're going to, for now, we're just going to move on to the next step. But our goal is to go, of course, even lower than 26 and decrease it as much as possible. Okay? And the lower this number is, the lower these numbers are, the more accurate our model is going to be. Okay? But for now, we're going to move on to step number 4, which is to use the model, or actually, let me just wait for some people to catch up before I move on to step number 4. So I'm going to give like 30 seconds before I move on to step number 4. Okay. Does anyone, if you guys have any questions, you guys can ask either me or Jacob or Elliot or anyone. So moving on to step number 4. Now we're going to use the model, and we're going to use our model to actually predict what the median value is now going to be. Okay? And the way that we're going to do this is we're going to do print, and we're going to actually do model.predict and independent. And for this one, you can actually choose any rows, any number of rows between the out of the 506 rows that we have. But to make it simple, we can just do colon and then 5. And if you remember, this is slicing from Python. If you remember, we can slice like arrays, lists, strings, right? So that's what it's basically doing. We're getting the first 5, like these first 5, okay? And we're going to predict using these first 5, okay? And we're also going to compare it to our dependent. So we're going to compare our predictions to the actual value of the median, or we're going to compare it to the actual median value. So using our model, we're going to predict using these dependent variables. And then after getting our prediction median values, we're going to compare it to the actual median values right here. So rather than keep explaining with words, I'm going to show you. So here, we can see that our model predicted, for the first 5, it predicted 28, 23, 29, 28.5, 27. And the actual median value was 24, 21, 34, 33, and 36. So it's not that close, but it was pretty close. It was kind of like around that ballpark. So it's not too off, but it's not too close either. So there's still room for a lot of improvement, right? yeah, does anyone have any questions? This is how you do the Boston housing price. I'm gonna wait just a minute so that you guys can catch up. And if anyone has questions, you can also ask during this time. I don't think we have any questions. So, or wait, maybe we do. Yeah, okay, never mind. I'm just gonna stop streaming for a sec. We're gonna move on to something called deep learning, hidden layer. Let me just do something before that. Okay. So basically, let me share my screen again. So we're gonna learn about deep learning, and we're learning about something called hidden layer. Okay. And basically, what that is so let's look at this picture here. So let me actually compare it to the other picture. So let's see. Yeah, in this picture, we see that we have like two layers, right? We have the this layer and we have this layer, and we only have two, right? But we can also have more layers than that. So we can have layers in between the input and the output layer, and we're gonna call these the hidden layer. Okay, and we can have more than one hidden layers. Okay, so of course it's gonna have a lot more weights, a lot more biases, and yeah, a lot more layers, and a lot more perceptrons. So this is the hidden layer, right? And this is an example of one perceptron, right, that I was talking about. But now we can have more than that, okay? So in this example, we have the input layer, right? We have 13, and we have output, and we have 1y. And in the hidden layer, we have 5 h's. Okay? And basically, we're going to have 5 perceptrons going from the input layer to the hidden layer, because all of these independent variables go to each each of H1, H2, H3, H4, and H5. So we're going to have 5. And then we're going to have 1 going from the hidden layer to the output layer. Okay? So the way we're going to do this is we're going to have, so previously we did x equals, and then we, did dot layers dot input, and then shape equals 13, right? But we're going to add another line, and and that line is going to say h is equal to layers dot dense 5, which is the number of variables that we're going to have for the hidden layer. And activation swish is, I think it's like the best activation that we have so far, or something like that. But like there's different types of activation. But for now, we can just use swish in single quotation marks, because I think it's the best one so far. And of course, we're going to do parentheses x, because we're going from x to the hidden layer. So we're going from the input layer to the hidden layer. So, and that's going to require the x, which is the hidden layer. And for the y equals, we're going to do parentheses h this time, except we're going to do parentheses h rather than parentheses x, because now instead of going from x to y, we're going from x to h to y. So we're going to do parentheses h. Okay, and this is basically what I was talking about earlier. We're going to have 5 perceptrons going from the input layer to the hidden layer, and we're going to have 1 from the hidden layer to the output layer. Okay? And of course, as I explained earlier, we can have several hidden layers. Okay? So we can have, for example, 2 here, right? With each 5. Whoops. Okay? And of course, if we want to do this, we're going from one hidden layer to the other, so we're going to have to put the parentheses h again. And yeah. Next one. This is an example where we have 3 hidden layers, right? 1, 2, and 3. And yeah, that's it for hidden layers. Now we're actually going to try this for the Boston housing price problem. Okay, so we're going to go back to our model here that we created. And what we're going to do is we only need to change a few things, right? And explain what those were, right? So the only thing we need to change is, let's see. So, right, we need to add the hidden layer actually in the model. So you can do h equals and for now we can just have 5. And we're getting it from our input layer, so do x. And of course, make sure to change this to h. Okay, this is very important, or else we're going to get an error. So we have that. I think there's one more. Oh, wait. Before we do that, let me just, okay. I forgot to show you guys, but we can also get like the actual values of the weights. So if you remember, the weights are these lines that are going from one layer to the other. So we can actually get the values for that. And if you remember, these values, the negative 0.09832304, and all of those numbers are called weights. And they're calculated from our model. So we can actually get those values. And those values are going to be what we use for our mathematical model here. So y equals, and then all of our weights times all of our independent variables. Okay, and of course, the more we train our model, the more accurate our weights and these values are going to be. Okay, so that's how we check what our weights are. Let's see. Okay. So yeah, so basically, we see that, okay, so what I basically did here is model.summary is going to show you like a bit of the summary of like all the layers, basically. So we see here in the first layer, in the input layer, we're going to have 13 variables, right? And then we're going to go down to 5 variables, because if you remember, in our hidden layer, we specified that we wanted to have 5 only. So we're going from 13 to 5, and then we're going to 1, which is in our output layer. And the parameter number is basically okay, so let me just, the parameter number means, how do I explain this? So we're going from, okay, so we have 13 variables here, and then we have 5, right? In our example, we're going from 13 to 5. And that means that we're going to go from 13, right? We're going to have 13 weights plus 1 bias. So that's going to be 14, right? So we're going to have 14 things for 5, each of these 5 H's. And 14 times 5 is 70, and that's why it says 70 parameters. Okay, and for the same reason, we're going to have 6 parameters going from the hidden layer to the output layer. And that's because if we look here, we're going to have 1 weight, 2, 3, 4, 5, and the bias, which is the B. Okay, so we have 6. So this is just a quick way to see if everything is working out correctly. And in our case, it is, because we see that we have the correct number of parameters and the output shape is correct. Okay, so I ran this step. Let me just stay here for like 30 more seconds so that some people can catch up on typing. Oh, and by using hidden layers, of course, we're using deep learning, so our predictions are going to be more accurate than before. So I'm gonna actually we're gonna actually train the model now. Before that, let's just do 3,000 instead of 1,000 this time. So we're increasing the number. Okay, so that took quite a while, and that's because we increased the number by a lot. But as you can see here, the lost number is now considerably smaller. So previously, we went from 33,000 to like 26, right? But now, by using deep learning and by using hidden layers, we see that we went from 26, 27, to all the way down to 18, 19-ish, right? And that's a really big decrease, right? So we went down a lot. So, and of course, as I explained earlier, if this lost number is smaller, then that means that it's more accurate. So let's try actually using the model, and we can expect to see that our predictions are going to be more accurate. Okay, so for the first one, we have 24 when it was 30, and second one we have 21, and it was actually 25. Or no, it's the other way around. Yeah, we got 32 when it's actually 34, and then we have 30 when it was actually 33, and we have 36 when it was actually 30, or 30 when it was actually 36. And you can see that the numbers, like the accuracy sort of increased, but it's still not really accurate. So what we can do to increase our accuracy is we can actually add more hidden layers. So we can copy and paste, maybe increase this number to 10. And we have to change this to H, because now we're going from X to this hidden layer, and we're going from this hidden layer to this hidden layer. So we have to put this H, and for this one we have to put X. And we're going from this hidden layer to this hidden layer, so we have to put H again. And we're going from the hidden layer to the outer layer, or the output layer, so we have to put H again. And we're going to create our model. As you can see, we have more parameters because we increased the number of hidden layers. This time, let's decrease the number to 1,000 because yeah, it took quite a while last time. Or maybe let's do 100 for now. And let's see. Yeah. Okay, so we're going to need to train it more than that. Down even more. So, you know, it was like, I think it was like 16, or no, was it like 18, 19? But now we've gone down to like, the lowest is like 10, right? So like 10 to 12, which is another pretty big decrease. So now we can expect to see an even more accurate model, or more accurate predictions. So let's run this. Whoa, okay. Yeah, so the predictions got a little more closer to the actual median values. But yeah, so you can increase this number if you want and see if it gets more accurate, if you can get the model to become more accurate. But that's pretty much it for the Boston hidden, or the Boston house price, using hidden layers. I'm gonna share a link to this. And I will stop sharing. Does anyone have any questions? If you guys don't have any other questions, I'm gonna pass it to Elliot. Yeah, and I think that's it for machine learning today. But
should I start?
wait, yeah, you can go ahead. Yeah, Elliot's gonna go over Hackerrank programs. So yeah, go ahead.
So we're gonna start with Hackerrank programs, and this one's called division. And the task is the provided code stub reads two integers, a, b, and it says add logic to print the two lines, and the first line should contain the result of integer division, right, which is 2 slashes, and the second line should contain the result of float division, which just has 1 slash. And they give us an example, just like this. If they print it, it should show up like this. So this is really simple, right? They already gave us two variables. They gave us two variables with inputs, and all we need to do is print a, should be just like this, how they want it with integer division, print just like this. And if you run our code, it should run. And if you submit the code, okay. I'll wait for you guys to open the page, and then we can get started. So this is the link of our first problem. And if you open it, it should send you to this page. And I'll give you guys a few minutes to open all that up, so we can get started. Are we ready to move on, or are you guys still opening it up? Are we ready to move on? I'll give you guys 1 minute and then I think we're gonna get started. Okay, we're gonna get started then. Alright, I'm assuming everyone opened it up. And I'm just gonna restart going over this really quickly. So the task is a private code. They tell us to add logic to print 2 lines, and the first line should contain the result of integer division, just like this, and the second line should contain the result of float division. And they give us an example, just like this. And what we do, very simple, we just print out, we print out A, B, just like this, and print out the float division, just like this. And if you run our code, it should show up as this. And yeah, that's pretty simple. Do we have any questions on this problem? No? Alright, moving on. Next one is finding the percentage. And I'm also going to send the link in chat. So let's open that up real quickly. Okay, and oh, I think it's the same link. Alright, we're gonna do this one instead then. We're gonna do function instead. That shows the same link. So instead of the division one, yeah, it shows the same link twice. So let's open the write a function one. Okay, I'm just gonna assume everyone has opened that up. So write your logic here. Okay, an extra day is added to the calendar almost every 4 years, and it's called a leap day. And the year can be evenly divided by 4. And if the year can be evenly divided by 100, it's not a leap year. And if it can be divided by 4, it is a leap year. And the year is also evenly divided by 400, then it is. Okay, so if it's evenly divided by 100, it's not. But with 4 and 400, it is a leap year. So our task is, given a year, determine whether it is a leap year. If it is, return the Boolean true, and otherwise false. Okay. So we're just gonna start with if year. We're gonna do modulo 400 to check if it's evenly divided. And if that's equal to 0, then leap is true, right? So if year is evenly divided by 100, then we're gonna show false. Okay. If it's evenly divided by 4, then we're gonna show true, right? And then else, we're just gonna return leap. And it's gonna show false, so if any of these besides these run, it's just gonna show false. I'm going to run our code and submit it, and it should show as a success. Do we have any questions? Very simple. If it's even divided by 400, it's gonna show true. If it's by 100 false, 4 true, and everything else false as well. Okay, we're gonna move on with lists. And I'm also gonna send the link. I will give you guys a minute to open that up, and then we can get started. All right, moving on. Consider a list. You can perform the following commands. Insert E at position I, and you're going to print the list. Delete the first occurrence of integer E. Insert integer E at the end of the list. Okay? And you're going to sort the list and pop the last element of the list. And you're going to reverse the list. Okay? So first, we're going to make an array, and we can just call it list like this. And 4 in range. Like this, or range. Input string equals input dot split. So we're gonna make them into separate lists. We're gonna, right? It's like this. And we're gonna make something called command. And we're gonna make that the first. We're gonna make that the first index of the array, or the first array. So we do that by input dot slash. Input underscore string bracket 0, right? We're getting the first one. We're gonna do this. And just like this, okay? And we're gonna add an if statement. If command is not equal to print, then command is gonna add self into, where do they do it? Okay. So here's what you're gonna do. Like you're gonna add parentheses, you're gonna add a starting parentheses plus comma dot join and the argument from where we got from here. Just like that. Okay, so if and our else is, we're just gonna print L. Okay, so if you run our code, it should show we have an error on line 7. Give me a second. We're gonna skip this one for now. I'll find the error later, just so we don't run out of time. Our last one is called tuple. Yeah, and I'm gonna send the link to you guys. Oh, for this one, I just misspelled string. Yeah, okay. For list, make sure you just spell string correctly, and then you'll show a success in the code. Yeah, okay. Alright, I'm gonna wait for everyone to open this up. Alright, we're gonna get started. Alright, so given an integer n and n space separate integers as input, create a tuple t of those n integers. Then compute and print the results of hash t. So hash is one of the functions module, so you don't need to be, so it doesn't need to be imported. Okay, the first line contains integer n, denoting the number of elements in the tuple. And second line contains n space separated integers describing the elements tuple t. Okay. Print the results. They give us a sample input and a sample output. So what they just want us to do is they already gave us some code to begin with. So we're just gonna make tuple and then integer list just like that. And we're going to print out, like they said, a hash. And inside, we put our variable name inside. And if we run our code, it should work. Okay. Our next one is string split and join. Yeah, string split and join, and I'm going to send this link. Alright, I'm gonna start by reading the task. You're given a string. You're given a string, split the string with the space and join using a hyphen. Okay? So it gives us a sample input, this string, and you see inside it each has a hyphen inside each space. So what we do here is we really just, it's very simple. The variable a line dot, right? They give us line. We're gonna split and we're gonna add a space. Okay? And then we need to add a hyphen inside each space. So what we do is inside our quotes, we're gonna add a hyphen dot join and our variable name, and we're just gonna return it. And if we run our code, it should show up as a success. Okay? So this code is we're just adding a hyphen inside each space, and it should work just like this. Alright, moving on, we have mutations. Okay. Alright, so we have seen that the lists are mutable, they can be changed, and tuples are unchangeable, right? So they give us an example just like this. Our task is read a given string and change the character at a given index, then print the modified string. Okay, complete the mutate string function in the editor below. It has the following parameters. We have string, the string to change. We have the position, the index to insert the character at. And we have string character, the character to insert. And it returns the altered strings. So we have sample input just like this. And we have our sample output under. Okay. So what we can do is it gives us string position character. Second. All right. So we can start by, you have to return at the bottom. We can start by making a list of the, and then, right, of the string. Yeah. And we're going to get the position. And we're going to make it equal to character. Right? Character to insert. And we have our string. Okay. Dot join. Give me what? Okay, we're just gonna move on for this. We're just gonna move on. Sorry about that. We're just gonna move on to find a string, and we can move on to mutations later. So I'm gonna put this inside chat. So we can do this first. Some of you guys a minute to open that up. All right, for find a string, in this challenge, the user enters a string and a substring. You have to print the number of times that the substring occurs in the given string. It will take from left to right, not from right to left. Okay, then for format, the first line of the input contains the original string. The next line contains the substring. Okay. Dot format, output the integer number indicating the total number of occurrences of the substring in the original string. Here we have the concept. So I have to traverse through the length of a string and use a for loop. Okay, so they tell us to use a for loop. And we can first make a variable called count. And we're going to make that equal to 0. And we're using a for loop for I in range the length of the string. Okay. And we're going to add an if statement. If string starts with and we have our substring. Yeah. Our count is going to go, it's going to add by itself by 1, just like this. And we're going to return count. If we run our code, it should show up as success. Okay. So we're just going through our length of a string. Okay. All right, moving on. String validators. I'm gonna send this link into chat. Okay. So I'm gonna start by reading task. You're given string S. Your task is to find out if the string S contains alphanumeric characters, alphabetical characters, digits, lowercase, and uppercase characters. Okay? And so our output format is in the first line, print true if S has any alphanumeric characters. And it shows us here how we check, right? We use this to find the alphanumeric characters. We have to find the alphabetical characters. In third line, print true if it has any digits, true if it has any lowercase characters, and true if it has any uppercase characters. And it gives us what we use. It gives us the methods to use. Okay? So what we're gonna do, we're gonna print. Yeah. And then just like this. For C in S. Okay, so we have our S was our input. So just like this. And you're going to be doing the same thing for each one. Okay? C dot. For C in S. Like this. So we have one for alphanumeric characters, alphabetical, digits, lowercase, and uppercase, just like this. And if we run our code, it should work. Yep, just like that. Yeah, pretty simple. All right, moving on. We're gonna move on to text. Text alignment. So I'm also gonna send this into chat. All right, moving on. All right, we're gonna skip text alignment just because it takes a really long time. It's probably gonna take the rest of the class. And just because we need to move on fast, we're gonna move on to text wrap. So I'm gonna send this link instead. Okay. You are given a string S and width W. Your task is to wrap the string into a paragraph of width W. Complete the wrap function in the editor below. Wrap has the following parameters: string, a long string, int max width, the width to wrap to, and it returns a single string with new line characters where the break should be. Our input format is the first line contains the string, and the second line contains the width. So we have our sample input, and it says and it gives us 4 also. So each, right, you can see we have 4 characters going down just like that. Now what we need to do is we just need to return text wrap dot fill. Okay. And we just need to, just like parameters above, if we run our code, it should work. So we're just copying this into this, okay, using text wrap dot fill, and it should work. Alright, our next one, we're going to be doing string formatting. There's the link. Okay, given an integer n, print the following values for each integer I from 1 to n. So we have a decimal, octal, hexadecimal, and a binary. And complete the print formatted function in the editor below. Print format has the following parameters: int number, the maximum value to print, and the prints is the 4 values must be printed on a single line in the order specified above for each I from 1 to number. Each value should be space padded to match the width of the binary value of number, and the value should be separated by a single space. Okay, so we have a sample input and our sample output. Interesting. Okay, so what we're gonna do is we're gonna make a variable called width, and we're gonna get the length of, with brackets, 0 to b dot format number. Okay, and using a for loop for I in range to comma number plus 1, we're gonna print out this really long piece of code. With follow along. Alright, we're just gonna duplicate this because it's pretty much the same. But we're just switching these X and this with B. And we're gonna dot format. Okay. just like this. And if you run our code, it should work. Yep, just like this. It's a little confusing. We're just printing the values for each of these. Okay, our last one, capitalize. I'm gonna send the link into chat. Alright, moving on. You are asked to ensure that the first and last names of people begin with a capital letter in their passports. For example, we have this name, we have capitalization, just like this, Allison Heck. Given a full name, your task is to capitalize the name appropriately. And our input format is a single line of input containing the full name S. Okay, they give us our constraints. It gives us our sample input and our sample output. You see the first and last name capitalized, right? So what we need to do is make a for loop for I in S dot split, right? We're gonna replace S dot replace. We're gonna replace I. You're gonna capitalize it, okay? With this, capitalize. Yeah, and you're gonna return S. If you run our code, it should work. See, okay. See what they're doing around here. Okay, so only our first. Oh, okay. It was just our spacing. Okay. So this should work. Do we have any questions? If not, that's all we have. Right? Oh yeah. Any last questions before we move on? Okay. Well, I think that's all for today. Yep.